Hello? Hello?
Hello.
Can you hear me?
Yes, sir. I can hear
Okay, so what have you been doing in Pathfinder?
Sir, challenge your understanding. So I have some doubts in that question.
Which chapter?
First chapter, polynomials.
How much have you done? You have read the theory.
Yes, sir. I've read the theory and I've tried the solved examples.
Solved examples till where?
Sir, I've completed the solved examples, all the solved examples that they have given.
Okay, so which questions are doubts? Build up
Sir,
your understanding, you're finished. Build up
uh,
your understanding, check your understanding, all of
चेक
those.
योर अंडरस्टैंडिंग में सर कोई बच्चा है उसमें मैं सोच रहा हूँ कि एक और बार थिंक करके ट्राई करूंगा मतलब डायरेक्टली मैं सॉल्यूशन नहीं जानना चाहता
So what are the doubts now?
So challenge your understanding eighth one. And like I have no idea how to start. At least thing.
Question 8 is saying if capital A, capital B, capital C, small a, b, c, and k are all constants. Are all constants, then show that all the roots of the equation are real. Show that all roots of a square by x minus a plus b square by x minus b, c square by x minus c, so on till capital H square by x minus h. Okay, is equal to x plus k are real. Which are the other questions that are doubts? Question 8, what else? What are the other questions that you have problems in? How much have you tried? Hello?
Yes,
Hello?
sorry, sir. I thought I was. Yeah.
How much have
Hello.
you tried?
Yeah. Sir, in check your understanding. There are some doubts. Like I want to try it once more. I don't want to give up these one questions. Like ये challenge your understanding में कोई questions में मतलब कोई idea ही नहीं आ रहा तो those questions like कुछ hint मिल जाए कुछ perception मिल जाए उसके लिए मैंने ये वाला doubt पूछा
और कौन कौन से?
yes sir कुछ challenge your understanding में 9th है और 24 है and 36 and 23 37 31
You have tried all these at least once, right?
yes sir I've tried but कोई direction नहीं मिल रहा मतलब
Okay,
result
fine. So let's think about this one.
yes sir.
Show that all the roots of this are real.
Yes sir.
There are 8 fractions here. So
Yes sir.
it will be an 8-degree polynomial.
Yes sir.
Actually 9-degree if you multiply this side.
Yeah sir. 90
9-degree polynomial. Okay, so show that all the roots are real. Fine. So in a 9-degree polynomial, you will have either 1, 3, 5, 7, or 9 real roots, right?
Yes, sir.
Why? Because imaginary roots will occur in pairs.
Yes, yes.
So we have to
Conjugate
prove
pairs.
that these are not correct. It is having 9 real roots,
Okay.
right? So fine. In order to prove that it has 9 real roots, all the roots
Sir,
are
just
real.
can
Can
we do like
assume that what?
sir, can we by proof by contradiction we can assume that there exists a complex root and its conjugate pair will also exist and put the value something like that.
हाँ वही कर रहा हूँ.
Okay, okay.
Can assume x is equal to this is a root. So similarly, x conjugate p minus iq is also a root.
Yes.
And then you have to show a contradiction using
Yes.
the fact that these two are roots. So,
Okay.
so how will you show a contradiction? You will say that, okay, we'll write first a square by p minus a plus iq plus b square by p minus b plus iq and so on till h square by p minus h plus iq is equal to p plus k plus iq, right?
Yes.
That is the first equation. Second equation will come when you put the
P
same
minus
thing, but it will be
yes.
p minus a minus iq, right?
Yes.
Same thing, p minus h minus iq, p plus k minus iq is 2. Now,
We can add these equation.
you can try many things. You can, okay, so if you add it, what will happen? You will get sum of terms like this: a square by p minus a plus iq plus a square by p minus b plus minus iq,
Yes.
p minus a minus iq, and such terms will go from a to h on the left side, right?
Yes.
And here you will get 2 times p plus k, right?
Yes, sir.
So this side is purely real, this side is coming purely real,
Oh,
right?
yeah. Yes, sir.
So simplify this term can be simplified. You can get denominator would be p minus
P
a
minus
whole square
whole
plus
square.
q square, right?
Yes. Yes, sir.
And top part would be a square into p minus a minus iq plus a square into p minus a plus iq, right?
Complex part distance.
So what we get here is complex part will get cancelled. We get 2a square p minus a by p minus a whole square plus q square, right? Correct.
Yes, sir.
Okay. This is one term. There are many 8 terms like this, right?
Yes, sir.
Uh,
So simplify.
p minus b whole square यहाँ आएगा, p minus b. There are 8 terms like this which add up to this somehow. So still it is little
Yes,
weird.
sir. I went till this method and reached at this conclusion. So after that, I didn't know how to do it.
X is in the denominator is the problem. So
Yes, sir.
let's think. This side is purely real. This side is also coming purely real. So
Yes, sir.
then you have to show somehow what you need to get out of this is that Q is 0.
Okay.
If you can show that Q is 0, Q has to be 0, then it is done. Then it is not imaginary, right?
Yes, sir. Yes, sir.
So basically the hope is that somehow it will simplify and Q has to become 0. So
Okay, sir. I'll try this once.
no, wait 1 second.
Okay, sir.
I mean, that is still a very long simplification.
Yes, sir. That's simplification part is the
You can't really do it like that. I mean,
yeah.
there must be some other way to do something here. Show that all the roots of the equation are real. X plus k. X plus k. Wait, I think. Second. I think that method is too long, so we have to think of something else. So.
Yes, sir.
Uh, hmm, a square by x minus a plus b square by x minus b, h square by x minus h is equal to x plus k. So has real roots. What else can we try here? Um, the polynomial here, p of x, will be of the form, if you do a rough sense of what the polynomial looks like, it will be like this:
Yes.
x minus c plus h square x minus a x minus b. Everyone has 7 terms here, right? 7 factors.
Yes, sir. Yes, sir.
And this side it is x plus k multiplied by x minus a till x minus h, right?
Yes. Yes, sir.
So, okay, so bring all of this to one side. You have x plus k and x minus a, x minus b, x minus h minus all of these, right? Minus b,
Yes, sir.
minus c minus till h square, x minus a, x minus b, right? Till x minus g, this will go till g, right?
Yes, sir.
Equal to 0. This is my equation, right?
Yes, sir.
This has 9 factors. These have 7 factors,
Yes.
right? So first of all, let's call this equation p of x. P of x is a 9-degree polynomial. We can find out the values of p of a, p of b and all, right?
Yes, sir.
P of A,
0.
P of B, and so on, so on.
And KKI. A
So
plus.
let's see
0.
what P of A is. It will be A plus, is it this term is 0? This term is not 0, right?
Has no 0. Yes, sir.
Right. All the
That's
other terms are
perfect.
0. So it is minus A square, right?
Yes, sir.
No. So minus A
No,
square,
no,
A
full
minus
factor,
C,
7 factors.
A minus C, right? Into whatever.
7. Yes, sir.
7 factors till, let's say, A minus H, right?
Yes. Similarly, we can do for BCH.
1 second, यहाँ पे missing factor was X minus A. So everything else is there. Yeah. Fine.
Yes, sir.
P of B. P of B भी ऐसे ही आएगा. P of B will
Yeah,
be
B
minus
square वाला term.
B square. And first factor X minus A will be there. So you put B minus A, right?
Minus A, B minus C. Yeah.
B minus C and so on. And finally, okay, doesn't matter actually. ऐसे ऐसे करके till P of H you can get minus H square, H minus A, H minus B, H minus G, right?
Yes.
Okay, so now what we can assume is, let's say the A, B, C, H numbers are on a line, number line like this, right? Without loss of generality, you can assume they are like this.
Yes.
Obviously, they could be in some other order, but then we can rename them, right?
Yes, sir. Yes.
There has to be some order on them, right?
Yes.
So now we can try and think of the signs of these, right? Correct.
Yes, sir.
Because the sign will tell us what is the value of P of A, P of B, and so on, right? If
So
there is a
P of,
sign change, then there is a root between,
yes, sir. Yes, sir.
right?
Yes, sir. So
P
P
of
of A
0
is
also you can check. I mean, it's fine. Let's just figure out first P of A, what is the sign? So P of
P
A,
of A is negative. Yes.
how do you know?
Sir, in
There
A
are
minus B,
7
A minus C,
factors
M.
here,
No.
and
Yeah, so
A is
then it's
lesser
positive.
than all of them, right?
Yes, positive. Yes.
So 7 negatives will be negative and then negative, so positive.
Yes,
right?
sir. Positive. Positive.
And this, right? P of
And
B,
negative.
B minus A is a positive factor,
Yes, sir.
and 6 negative
6
and 1
1
7
negative.
negative, right? So this is
Yeah.
negative, right?
So that contains one root in between.
So there will be one root in between. There will be one root. ऐसे करके sign keeps changing one by one, no?
Yes, yes.
Many roots you can confirm already, right?
Yes, sir.
See, between A to H, there will be 7 roots are confirmed, I think.
Yes, sir. This is alternate sign will keep on.
Alternate signs it will be, and 7 roots are confirmed already. Now,
Yes, sir.
can you find one extra root? If there is one more extra root that you can find, then we know it has to have
Then
9.
the question is over. Yes, sir.
Right? So
Yes.
if this is positive, can you find a value where it will be negative before this? Or maybe last one is what? Last one sign is all are positive and this is
So
negative.
negative.
Right? So last one is negative. So can you find a value which is positive afterwards, right? Right?
Yes, sir.
So that there is an extra sign change. Correct?
Yes. Yeah. So if then then there will be a root between H and that positive sign.
Yeah.
And then
So we have to look for at least one place where there is an extra root. So 0, where what is the value at 0? It will be, okay, so if you put 0, we don't know, right? It will be k into
variable.
so many things. Okay, x is equal to minus k. If we put what comes, right? x is equal to
Yes, sir.
minus k. Now there are multiple cases. K could be somewhere here, k could be somewhere here, or k could be somewhere here, right?
In between.
Somewhere, right?
Yes, sir.
At least these cases are there for k, right? K can be
Yes, sir.
lesser than a, k can be greater than h, or k can be somewhere
Or
in
in
the middle,
between.
right?
Yes, sir.
If you carefully work through all the cases, right? Let's assume for now that k is less than a, right?
Yes, sir.
K is less than a. Let's try to put the value of p of minus k, right? Because that makes the first term 0. And after that, we have to similarly find the sign, right?
Yes, sir. But the rest of the terms does not contain a k term, right?
Nay. So because we have said k is less than all the things, so all factors are negative, right?
Yes, sir. No, we have substituted. Yeah, yeah. Yes, sir. Yes, sir.
All factors are negative, so my 7 negative, 7 negative, and 1 positive, right?
Yes, sir. Yes, sir.
So this factor is positive. Similarly, everyone will be positive, right?
Yes.
So P of k becomes positive, which is what we, I think, wanted a positive above, right? First वाला क्या आया था ये? P of a.
Positive.
P of a had
Positive.
come as positive.
Yes, sir.
Okay, then this doesn't work if P of k below is positive, right?
Yes.
Then let's take the other case if k is above everyone, right? Correct.
Yes, sir.
So then you can easily see that P of minus k, first one will be 0. And after that, all the other factors are positive and minus a square will be negative. So it will become negative, right?
Yes, sir. So between P minus K and PA, there is this
Between P minus k and
PA.
PA. If k is above, right?
Yes, sir.
तो एक रूट आ रहा है ना उसमें.
So total 8 roots, so there should be 9 roots.
हाँ.
Yes.
So this method is like, it's based on basically the idea that between any two change of sign, there will be a root,
Yes, sir.
right? So that idea you can use because the normal method is giving too much calculations,
Yes, sir.
right?
Yes.
Obviously, this is not like a perfect proof and all. You have to like write it properly if you have to write it in
Yes, sir.
the
Yes.
exam. But the idea is this, I think. You have understood, right?
Yes, sir. Yes, sir.
The next one is which one? Ninth one.
Sir, before ninth, can you please explain that question 36? Because I've been trying it for like 1 week and I'm not getting any idea.
Question 36.
Yes, sir.
There is no guarantee that I'll be able to solve it. Obviously, this is a Putnam question, but I mean, nobody can guarantee anything in
Yes, sir. Yes.
especially Olympiad maths, so it's fine. We can try with real coefficients. Let Px be a polynomial with real coefficients such that P of x is greater than equal to 0 for all real x. Okay, fine. Prove that P of x is equal to f1x whole square plus f2x whole square plus fnx whole square. Okay.
Also, sir, in this question, like they have defined F1, F2, Fn. Like, how is that F1, Fi defined in general?
I think that
Like it could be.
anything that is weird though, but
Yes, sir.
I feel like something is missing. I mean, we can find the question online, right? Just
Yes, sir.
try
I'll
to
just
find the
check.
question once online and see if the question is complete.
Yes, sir. Just once. Six. $19.99, sir. It's not sure.
Hmm.
1999. The question is not there. Guys.
Question you found?
No, I'm not.
Putnam 1999.
Yeah, it's Putnam 1999. There is no question as such.
There is no question as such.
Yes. Yeah, it's not there.
1 second, I will also check once.
I sent on WhatsApp also. 1999. Yeah, it is. This is A2 question, I guess.
1 second.
It's written show that for some fixed positive and we can always express a polynomial with real coefficient, which is nowhere negative as a sum. I guess this is the
Does he say anything else? Like,
no much. Like it's written show that for some fixed positive n, we can always express a polynomial with real coefficients, which is nowhere negative as a sum of the squares of n polynomial.
some of
Nothing
the
more.
squares of.
Some of the squares of n polynomials.
Okay, so then at least f1, f2, and all are polynomials, right?
Yeah.
1x, f2x are all polynomials.
Yes.
Okay. Px is greater than equal to 0 for every real x. Hmm.
If when
Thinking 1 second.
yes, sir. I'm also-
Hmm.
Yes. You-
Okay. Real coefficients px is greater than 0 for all x. For all real x.
So,
So if it was a quadratic, it would have been above.
yeah, discriminant greater than that. equal to 0.
Discriminant will be less than equal to 0.
Yeah, sorry, less than equal to 0. Sorry.
Uh, but it is not a quadratic, it could be any polynomial. So
Yes. Like I guess we should. I've seen in many tough problems what many like basically sometimes the approach is to solve the small problems and then go to the higher problems. Like first we try for quadratic and think, okay, so this is the idea, then we go for cubic sum. I guess maybe that's the approach.
you can try that, but in general,
In general, then we can go if you can see some like pattern or
I think you have to do induction. So
yeah, for induction we need to understand the base cases.
hmm,
Yes,
so if P of X is equal to 0, like case 1
then
is,
F1, F2, all is 0.
so then all the F1x, F2x and all are all identically 0.
Yes.
Case 2 is P of X is greater than 0 for all real X, right?
Yes.
So if P of X is greater than 0 for all real X, that means it has like imaginary roots, right?
Yes, sir. Yes.
Imaginary roots. So that means, first of all, that it cannot have odd degree,
Yes.
right? Because any odd degree polynomial will have at least one real root,
Yes, sir.
correct?
Yeah, yes.
Do you understand that? It has to have even degree, right?
How did you say, conclude? Like, I didn't get that.
It cannot have odd degree because again, like last problem, any odd degree polynomial with real coefficients will have imaginary roots in pairs, right?
Yes, sir. Yes.
So if there are 2n plus 1 degree polynomial, then it has to have 2n plus 1 roots, and then one real root has to be their minimum.
Yeah. So they're all will not be complex.
So it cannot have odd degree. It has to be some even degree polynomial,
Yes.
right? Even degree. Then only it is possible to have all imaginary roots,
Yes, sir. Yes.
right? So if it is an even degree polynomial, like let's say 2n degree, then you can say that a plus ib, a minus ib types of roots will be there, right?
Yes.
N pairs like this, right? Correct.
Yes. Yes.
So if a plus ib, a minus ib pairs are there, then if you think about it, that means what kind of factors are there? X minus a plus ib and x minus a minus ib, right? X minus a
Yes. Sir.
plus ib,
Plus, yeah.
right? So,
Yes, sir. Yes.
so if you multiply these two together, you will get factors of the form x minus a whole square plus b square, right?
Yes, sir. So it's real.
And then only this will be one factor, and similarly there will be n factors like this, right?
Yes, sir. Yes. Sir.
In general, for px, it will be n factors with such factors, right?
X
Correct.
minus C
So
plus
if
D.
you multiply, now you can easily see that it will become this, I think. If you like now we can do the thing because induction will work now. Induct on n, right? Suppose base case n is equal to 1. See, it is already a polynomial x minus a whole square plus a constant polynomial square, right?
Yes, sir. Yes, sir.
Right?
Yes.
समझ में आ रहा है?
हाँ सर आ रहे हैं. Yes.
If you take two factors like this
हाँ
and you multiply it out, you will be able to construct it like sum of two square polynomials, right?
Yes, sir.
Because it will have
Yes.
four terms, you can just make four polynomials like that. X minus a whole square is 1, b square, b into x minus c is 1, right?
Yes, sir.
So the question is done, I think, because I mean you have to write it nicely, but one case was
Yeah.
p of x is 0, then all of them have to be identically 0. The other case is when px is greater than
Yeah.
0,
Yes. Yes, sir. Yes, sir. I got it.
cannot have odd degrees, so all the even degrees only it will be. So even degrees, the roots will be like this, so the factors will be like this, so it will look like this factors.
Yes,
And
sir.
then
Yeah.
when you multiply,
I got it.
you will always be able to make it look like this.
Yes.
Right. Okay. What else?
Question 9, sir.
Question 9. Prove that there does not exist a polynomial. Prove that there does not exist a polynomial p of x is equal to a0 plus a1x plus a2x square plus so on an x power n, such that p0 p1 p2 till where forever are all prime numbers. P0 p1 p2 so on means for all integers, right?
Yes.
For all integers is prime. There does not exist a polynomial such that this thing is prime. Okay.
And use proof by contradiction.
So you'll assume that there is a polynomial like that. Assume that px is like that, satisfying the property. So that should give you p0 is equal to a0 is prime, right?
Yes, sir.
And p1 is a0 plus a1 plus an is prime, right?
Yes.
Okay. And p2 is a0 plus a1 into 2 plus a2 into 2 square plus an into 2 power n is also prime. So, okay. Sum of two prime numbers cannot be a prime number because it will become even
Yes, sir.
unless one of them is 2, right? So first of all, we know that a0 is prime. Case 1 is a0 is equal to 2. Case 2 is a0 is greater than 2, right?
Yes.
So in case 1, if a0 is 2, then we have a0
Yes,
plus
and
a1.
you said that sum of two primes can't be prime, but what if either of a1, a2, a3, an could one of them also be like they are not unique. One of them could also be two.
No, the thing is that any two primes cannot you except if there's two, right?
Yes, sir. So in that set A0, A1, A2, there can be multiple tools appearing.
Multiple twos could be there. Uh,
We classify all the cases and it will be longer.
multiple twos could be there. So A0 plus A1 plus still AN is prime. So if, okay, fine, we'll not worry about that right now. We'll worry about this at least. And from here, we can say immediately that 2 does not divide A0, right?
Unless it's A0 is 2. Yeah,
Oh,
no, yes, sir.
this is guaranteed, right?
Yes,
Because if 2 divides A0, then this is not a prime.
yes, sir, yes.
So similarly, you can say 3 does not divide A0 because
Yes,
P
sir,
of
yes.
3, right?
Yes.
Right? And 5
So
does
yeah,
not divide
we
A0.
get that. Yeah, yeah. So it's all solved because then that would mean that A0 is a composite number.
I mean, you will can start
Yeah.
taking all the primes and you will get that A0 is not divisible by any prime,
Yes, sir. So it
right?
has to be 1.
A0 has to be 1 then, which is not a prime.
Yeah, yeah. Yes.
That is a contradiction,
Yes.
right? So basically, don't worry about the first two. You can start from P2, P3, P5, and so on.
Yes.
And it will imply that A0 has to be 1, which makes A0 not prime, right?
Yes, sir.
Okay. What else?
24.
Which one?
24. 24.
Px, Qx, Rx, and Sx are polynomials. Polynomials such that P of x power 5 plus x times q of x power 5 plus x square r of x power 5 is equal to x power 4 plus x power 3 plus x square plus x plus 1 multiplied by s of x. Okay. Prove that x minus 1 is a factor of p of x. X minus 1 is a factor of p of x. Okay, so basically we have to prove that p of 1 is 0. Right? Correct.
Yes, sir.
Okay. So polynomials, this equation is valid for all x. So that should be very useful because we can put any value of x here, right?
Yeah, so
So
P0, I guess, equals S0. No, yeah.
P0 equal to S0. What are we getting equation? Second equation, P of 1 plus Q of 1 plus R of 1 is equal to 5 S
Yes,
of
yes.
1, right?
Yes, sir.
Correct, no?
Yes, sir.
This thing suggests that we write it like x power 5 minus 1 by x minus 1.
Yes, sir.
That is a common factorization that you need to know, right?
GP.
ये पता है ना?
Yes, sir. GPA.
Mhm. So let's write the equation like this: p x power 5 plus x q x power 5 plus x square r x power 5 is equal to x power 5 minus 1 by x minus 1 s of x. And we
Yes,
can
sir.
multiply by x minus 1 on both sides and put x minus 1 p of x power 5 plus x into x minus 1 q of x power 5 plus x square into x minus 1 r of x power 5 is equal to x power 5 minus 1 s of x, right?
Yes, sir.
Okay. Again, I don't know if that was useful, but what we can say is prove that x minus 1 is a factor of p of x. So, hmm, maybe that was not very useful. We have to think of something else. Uh, if I put 2, what will come? P of 32, 2Q 32, 4R32 is equal to 31 S30, S of 2. So that also P of 32 will come as 31 S32 minus 4 SR32 and 2Q32, right?
Yes, sir.
But that will not help us, I think. Uh,
Yes, sir. Yes, sir.
hmm. Polynomial such that P of 0 and S of 0 are same. So they have the same constant term, right?
Yes, sir.
P of 0 and S of 0 have same constant term. Uh, okay, what we can try to think here is think of the degree of these polynomials, right?
Yes.
So uh, P, Q, and R, like if they have equal degree, P, Q, R, S, right? If all of them have equal degree, then we have this side is becoming a degree n plus 2.
Yes, sir.
No,
No,
actually
yes, sir.
5n
Yes.
plus 2, right? 5n plus 2, no?
Yes.
Because
Yes, sir. Yeah.
when you replace p of x with p of x power 5, the degree becomes 5n,
Yes, sir.
right?
Yes.
So let's assume for now that case 1 is when p, q, r, s have same degree. That is obviously a special case. And let that degree be n. Then this
Yes, sir.
side degree is 5n, 5n plus 1, 5n plus 2. So it becomes basically 5n plus 2, right?
Yes.
5n plus 2 this side. This side is n and 4, n plus 4, right? Correct.
Yes.
So you're getting 4n is equal to 2, right?
Yeah. So
N is
anything.
equal to half, which doesn't make sense.
Yes, sir. It's not a point.
So that means our assumption is wrong, right?
Yes, sir.
Correct.
Yes, sir.
Our assumption must be wrong then. It doesn't have same degree then. Okay, we are Still not close to the solution yet. We'll think p x power 5 plus x q of x power 5 plus x square r of x power 5 is equal to of 4 plus x power 3 plus x square plus x plus 1 s of x. If I multiply all sides by x minus 1, p of x power 5, I will get this x square x minus 1 r of x power 5, and here x power 5 minus 1 s of x.
That is the previous equation.
And that was what we got earlier also. But what we know that okay, maybe it is it must be something really simple because it is USA Maths Olympiad. It cannot be hard. 1976 question can't be hard. So
Yeah,
we
previous.
are missing something very simple. So think P of 1 was coming as P plus Q plus R 1 was equal to. Yeah, I'll just isolate P of x power 5 is equal to this x power 4 plus x cube plus x square plus x plus 1 s of x minus x q of x power 5 minus x square r of x power 5. This is P of x power 5. And okay, so I will check 1 first. P of 1 is coming out to be 5 s of 1 minus q of 1 minus r of 1, right? Let's put, if you put minus 1, you'll get p of minus 1, right?
Yes.
P of minus 1 will be 1 minus 1 minus 1 s of minus 1 minus minus plus minus q of minus 1 and minus r of minus 1. Okay, p of 0 is basically s of 0. Hmm.
Earlier question.
Hmm?
Yeah, this one we have already done.
What are you saying?
No, sir, I was thinking.
Something simple we are missing. Think a little. We'll think a little more. 1 second. X minus 1 is a factor of p of x. How can we prove that this is 0? Right? This is ultimately
Yeah, this is a
q plus r at 1 is adding to 5 times s of 1. So mm, Okay, I'm not getting it right now. I'll think about it. Something very simple it has to be because seems like a doable one. I mean, there is a brute force method is there obviously, but I don't want to do that. So, I mean,
Like what, sir?
like you can just take P as degree N M O P or something, right? And you will get conditions on the degrees. Like, you understand what I'm saying? Like, this will be degree 5n, right? This will be
Yes.
5m plus 1. And this will be 5o plus 2, right?
Yes.
And let's
Yeah.
say this is q. So this will be q plus 4, right? Correct. These are the degrees that I'm writing, right? Are you understanding what I'm saying? Hello?
Hello.
I'm
Hello.
saying that the degrees
Yeah.
here are these, right?
Yes, sir. Yes.
Then now what has to happen is degree on left hand side should be equal to degree on right hand side because this equation, this identity is true for all x. That will only happen if degrees at least for the polynomials on both sides are matching, right?
Yeah. Yeah. So
So
we have to equate, but there will be many variables, like 4 variables. One
नहीं,
diagonal.
4 variables नहीं होगा. The degree will be whichever is greater out of these, no.
Ah, yeah. No, yeah. Sorry. Yeah.
Depending on n, m, o, the order of that, right?
Yeah.
So you can take several cases, but ultimately the maximum of these three numbers, right? Max NMO, that decides the degree, right?
Yes.
So that will be equal to Q plus 4, right? Correct.
Yes, sir. Yeah.
So if O is the maximum, for example, right? Then 5O
Yes.
plus 2 will be greater than all of these, right? So
Yes.
5O plus 2 will be equal to Q plus 4. And that means you are getting 5O is equal to Q plus 2, right?
Yes.
So
So we can write.
Q could be 3, O could be 1, right?
There will be several.
There will be many possibilities, but uh, O cannot be 1 because M and N has to be lower than that, right?
Yes, sir.
Right. If this is 2, then Q has to be 8, right?
Yes, sir.
Correct. And if this is 3, then it is 13. It's like that, right? Basically, Q
Yes.
is 5O minus 2, right?
Like, sir, in that we found that P0 equals S0. We could make a new polynomial like say gamma x and say that P it is equal to Px minus S of x and say that 0 is the root of that.
Mm-hmm.
Yeah,
P
that
of 0 was S of 0. So 0 is a root. Yeah, that is correct.
yeah, and then we can write P of x minus S of x as a new polynomial and say that 0 is the root of it.
Hmm. P of
So if we like x equal to 0 will be a root of this new polynomial that we just put.
but उसके बाद कुछ नहीं हो रहा है ना. I mean, that is correct, but I mean, you have to handle the x power 5 stuff. This is x power 5 minus 1 by x minus 1 s of x. Okay, I'll think about it. Right now, it is not solved, but you also
Yes.
try it. I will see what has to be done here. I'm sure it has some easy solution, but right now I'm not getting it.
Okay. Okay, sir.
Try question 24 again and try the rest of the stuff.
Yeah, sir. Okay, sir.
We'll discuss next week whatever else doubts are there.
Okay.
Okay, that's all for now.
Thank you, sir.
Mm.